Hey folks, I got a couple brief, simple examples using electric flux and kind of using Gauss's law. So my first thing I'll note is from the previous video, so I've kind of written this all down. So net electric flux leaving an enclosed volume, all right, which is a closed surface that would enclose a volume. That equals to the double integral of E dot dA around the closed surface, which also equals Q in over epsilon naught. So a couple things to note. If we want to find in a previous video, and I'll scroll up to that, in a previous video, we talked about the electric flux leaving a cube. And if you were to use this equation to try to calculate the electric flux leaving, let's say, the right-hand face here, it would be really, really hard. But now we have an easier way to do that. We know that the electric flux, the net electric flux leaving a total surface, is Q in over epsilon naught. So assuming this charge is centered in the cube, then the total electric flux leaving the cube would be Q in over epsilon naught. Well, how much total flux would leave one surface? Well, there are 6 surfaces, so the total flux leaving this right-hand surface would be Q in over 6 epsilon naught, or 1/6 of this. So that's a nice, easy way, a nice, easy example to figure out like how much total flux leaves a surface. Now, note, finding the electric field over this would still be difficult because the field varies. But finding the total flux leaving that surface would be quite easy, okay? Now, as far as electric flux goes, I'm going to do a few more examples here. Let's say I've got the following situation. I've got a positive 2Q here. I've got a negative 3Q there. And let's say, let's first say, what if I asked you to draw the electric field around these two charges? Okay, so you'd have field lines going from the positive to the negative, all right? You'd have a few leaving here, like so. You'd have more entering this one because it's larger, okay, like so, okay? And I asked you to figure out the net electric flux leaving the following surfaces. Here's surface A. Here's surface B. Here's surface C. And here's surface D. Okay, and I don't want to know electric field strength or anything. I just want to know the net flux leaving each of those surfaces. Well, the net flux leaving surface A would simply be Q in over epsilon naught, which, what's the total charge that's inside surface A? It's positive 2Q. And then you just divide that by epsilon naught. Now it's positive because you have field lines leaving that surface. How about the net electric flux leaving surface B? Well, what charge is inside of there? Well, it's negative 3Q over epsilon naught. And notice that it is indeed negative because field lines are entering that surface. How about the net electric flux leaving surface C? Well, how much charge is inside surface C? Well, there isn't any. So the net flux leaving surface C would be 0. Now, be very careful. This is really important, okay? Don't confuse the net electric flux entering or leaving a surface with the flux at different parts of the surface. So for instance, now if I draw a few more field lines in here and fill this out like so, okay, there is flux there. There are field lines entering the surface there. That would be a negative flux, okay? There's also a positive flux here. There's field lines leaving that surface there, okay? So there is flux at most parts of that surface, okay? This just tells us the net flux. You'll notice that the way I've drawn this, there's 2 field lines entering and those same 2 field lines leave. So because there's no net charge inside that surface, the net flux entering the surface and the net flux leaving will be the same. So be very careful. There's like 3 different kinds of questions that we could ask here. I could ask you, what's the net flux leaving that surface? And your answer is 0. I could say, what's the flux in this part of the surface? And you would say negative. Or the flux at this part of the surface, you would say positive. And then I could say, is the field 0 anywhere along that surface? And your answer is no. There's red field lines everywhere along that surface. So if I asked you what's the electric field strength, okay, that is not 0. There's a number for that. Now, calculating that would be fun, but you could calculate it. And then finally, what's the net electric flux leaving surface D? Well, surface D encloses everything. There's a positive 2q and a negative 3q. The net charge is negative 1q over epsilon naught. So that would be your net flux leaving surface D. Now notice it's negative because we have more field lines down here entering than we do leaving up here. We have 3 lines leaving, and the way I've drawn it, we've got 5 lines entering. So that's why you have a negative. Remember, negative means entering and positive means leaving. Okay. All right. In the next series of videos, we're going to talk about using Gauss's law to calculate electric field strength for different situations. So that's what we're going to be doing for most of the rest of the chapter. I hope this video was helpful, and thank you very much.